Start this one.
What's that at?
Is 7/1?
Yep. Then what?
Cross multiply.
So 41 equals 7 times 1 plus 14.9 e to the negative 6x. Then what?
This is not logarithms, right?
It's going to be.
Distribute the 7.
Okay.
Was there something you could have done differently?
I could have divided both sides by 7, but this is fine.
Why divide?
This will still work.
I just go to the constant, not the exponent.
Right. Then what?
Subtract 7. Oh, this is this one.
Then what?
Is it 104.3 equals?
I got to start getting the x by itself, and I have to start getting the things that are attached to
Then
the
you
x
need
by
square root.
itself. Nope.
I don't know. If it's the x, how not square root?
Well, right, I want to get the x by itself, right? But the x is part of the e, so I have to get the e part by itself. What's keeping the e part from being by itself right now?
104.3.
Correct, so I need to eliminate that now.
Divide it?
Oh,
Mhm.
okay.
All right, now what?
Now we're
I need
square
to
root.
log it.
Lateral.
I'm going to log it.
Ah.
Log it. What undoes e?
Natural log.
Natural log. So I'm going to natural log both sides. Now this becomes a coefficient out
Oh,
front.
okay.
So I get the natural log of 0.326 equals negative 6x natural log of e. What is the natural log of e?
I thought it was 2.73.
No,
E is, but when you natural log e, they undo each other and you just get 1. Yep. So I don't need that anymore. Now I just divide both sides by negative 6. And x is going to come out to be whatever this turns out to be in my calculator. So the natural log of that decimal divided by negative 6. I get 0.187. What else? Okay, 29.
Oh yeah.
This one says verify that these two functions are inverses of one another. There's 2 ways to do that. Anybody remember them?
No idea.
What's that?
You set them equal to each other.
Just
Nope.
wait. Can't you just start like subtracting and things? Like.
Nope.
Why?
I want to show that one is the inverse of the other. That one
Oh.
You have to
undoes the
multiply
other.
with reciprocal?
No.
Substitution.
They're.
You divide by 1.
Oh my gosh. You guys have forgotten everything.
Yeah.
Okay. There's 2 ways to do this. You can take one function and put it in the other one.
Oh, yeah.
And if everything simplifies out to just be a plain old x, they're inverses. Or you can take one of them, find its inverse, and then show that it equals the other one. I would take either method.
Oh, so we just flip that fraction. G of x is basically 3 and then x plus 1.
No, it doesn't work quite like that.
No.
Right? Do you remember how to find an inverse of something, first of all?
Apparently not.
Okay. Let me rewrite this one first. How would I start finding the inverse of this?
Put everything over 1.
Nope.
Oh, switch.
Swap the x and the y,
Oh yeah.
and then resolve for y. Now what?
Minus 1. Divided by 3. And cube root.
Now, does that equal this?
Yes.
Yeah, it does.
It does, because the cubed root really means x minus 1 over 3 to the 1/3. They are the same thing. Okay? That's one way to show it. The other way is to take the one function and put it in the other function. So we go, let's say, f of g of x. So I'm going to take this g function and put it in for that one's x. So that'll get me 3 times x minus 1 over 3 to the 1/3 cubed plus 1. All right, and then you just kind of start simplifying it out. What do you do with a power to a power?
Add them.
Nope. Multiply them. So what is 3 times 1/3?
1.
1. Okay, so I don't really need that anymore. Now when I multiply these two things together, what happens with the 3's? So now I've got x minus 1 plus 1. What's that?
X.
So that proves that they're inverses of each other. So either method, and it doesn't matter which direction you go in, if you did it g of f of x, it still would have worked. If I went g of f of x, so we're going to go in the opposite direction, I'm going to take this one and plug it in here. So now I'll have 3x cubed plus 1 minus 1 all over 3 to the 1/3 power. All right, so simplify things. Well, plus 1 minus 1, that leaves me with 3x cubed over 3, 1/3. These cancel, so now I've got x cubed to the 1/3, which is just x, because power to power, I'm going to get x to the first. They got to be inverses of each other. So it doesn't matter which order you go in. Or if you just want to pick one of these and solve for its inverse and then show that it has to equal the other one, that works too. Anything else?
30.
Oh yeah. Same problem. So which method do you guys like the best?
Neither.
Replace the x and the y.
Swap the x's and y's?
Yeah.
Okay, so this will be y equals 1/3 x squared. All right, so that'd be x equals 1/3 y squared. What do I do first? Solve for y. Divide by 1/3, which is the same thing as multiplying by 3 over 1. So I get 3x equals y squared, then what?
Square root.
So y equals the square root of 3x, or 3x to the 1/2. Did I get what I needed?
Yeah.
Yep. Any other ones?
Seems simple enough.
Yeah, my guess is on a multiple choice one. I wouldn't ask you to do this because this is a proof, but I would ask you to, which one of the following functions is the inverse of the one I gave you? And then you'd have 4 to pick from. So you'll have to be able to at least do the inverse part. So this is not a bad method to practice.
Are we allowed a scrap sheet of paper for work?
Oh yeah,
Okay.
I'll supply you with one.
I need many.
Many. I'll
Yeah,
supply you with
many.
funding. Any other ones?